This is Lake Maggiore in Varese, north of Milan. The town here is Ispra, which lends its name to the Ispra Joint Research Centre. At the centre, scientists work on ways to control the export of dual-use material and also to prevent the trafficking of nuclear material and on nuclear safety generally. This is the EC's Joint Research Centre, and these are some of the 2,000 or more people, many of them scientists, who work here. In fact, it's one of 7 such centres in 5 member states, and its headquarters are in Brussels. They provide the science to inform policy decisions to ensure that the EC have a safe, secure and sustainable future.
We help the harmonized implementation, as I would say. So just like we help by developing instrumentation which is used at border to detect radioactive equipment, we also help understanding other things which may be on the same track and need to be identified as dual-use items or not.
Well, what we do in our activities is we collect and we validate environmental radioactivity data which we receive from the competent authorities of the European Union member states. And we do that for routine and for emergency purposes.
Under the label nuclear security, actually we tackle different issues. We tackle non-proliferation and nuclear security stricto sensu, which addresses threats posed by subnational actors.
So if we focus on nuclear security, the keywords here will be physical protection on one hand, so prevention of theft, and then you have the accounting of the material. You want to make sure that you know at exactly how much material there is at each point in time. The operator which uses the material cannot divert material for malicious purposes.
Here you see the maximum of the radiation profile that corresponds roughly to the back of the van. So already we have a preliminary information that helps us to locate correctly the potential radioactive source inside the vehicle.
What you also notice during training that people tend to be afraid of radiological nuclear material. So the psychological value of being trained on real, genuine nuclear material, being able to find it in the car, being able to touch it with your hands, and in the evening realizing you're not becoming ill, you will not have health consequences, that's a very important issue.
Questo è il controllo che viene fatto normalmente in una dogana quando un veicolo passa attraverso un portale di radiazioni e fa scattare un allarme. Ci dice che c'è qualcosa di radioattivo all'interno del veicolo e dobbiamo investigare per capire se si tratta di una radioattività dovuta a normale materiale radioattivo come possono essere le ceramiche, i fertilizzanti che contengono per sé della radioattività, o se c'è qualcosa di illecito. In questo caso abbiamo identificato un cobalto 60 che è una sorgente radioattiva tipicamente usata o nell'industria o nella medicina per scopi diagnostici e che quindi non dovrebbe normalmente essere trasportata se non accompagnata dalle dovute documentazioni per trasporti legali, mentre invece se trasportata illegalmente costituisce un pericolo per la salute e per la popolazione.
The dual-use goods are those goods which have both civil and military applications. Can be used to develop normal, let's say, illicit activities, but also are instrumental to building nuclear weapons and non-explosive weapons of mass destructions. It's very hard for people to realize that they have in their hands something which is related to weapons of mass destruction. This is a pressure transducer. It's absolutely normal. I'm not going to show the brand, but it's absolutely normal. But it can be used also to measure the vacuum in a process chain which is used to produce dangerous materials. It's a huge list, over 200 pages and nearly 2,000 pieces of text, which means materials, software, technology, equipment, and anything.
The purpose of this instrument is to determine the mass of fissile material inside waste drums.
In this laboratory, we test usually devices that are commonly used by frontline officers in nuclear security. We tested here personal radiation detectors, spectroscopic radiation detectors, radioisotope identifiers, gamma search devices, and neutron search devices.
That material is transported from left to right, and then you're going to look at the country level, at the state level, towards the consistency of its declared activities with its present facilities, what they call state evaluation analysis. And they want to make sure that they have reasonable confidence that the declarations of the state with respect to all its nuclear activities is complete and correct. That we look, for instance, with satellite imagery towards what's going on in the country. If you find that there are particular indicators for nuclear activities which have not been declared by the state, you might very well want to ask a question to the state to explain. This is what happens today, for instance, in Iran.
The activities were started about 20 years ago, as I said, so it is the result of the Chernobyl accident. During the Fukushima accident, there was no need for that because the levels were appreciably lower. For the routine situation, we monitor or we ask to provide us information about all the matrices in the environment. So it goes from air to drinking and surface water, to milk and to mixed diet. There is a compliance with the basic safety standards, which for the emergency situation, the scenario is slightly different. The main difference for that is there is a need for real-time data exchange. And why? Because if there is a release to the atmosphere, the cloud resulting from this can go into any direction and can travel in very short times over a long distance. So people need to be informed about the progression of this cloud, and this is done typically by systems like Ecury and URTEC.
We have developed a specific tool for nuclear security that we call Nuclear Security Media Monitor. About 2,500 information sources of general news, this type of thing, and nuclear specific ones, which are about 150. And we have developed the keywords, which allows to filter somehow the information and to have it structured in a way which is suitable for the analysis.
But of course, over the past few years, we have another smaller scale dimension, which can be terroristic activities. The difference with that is, in fact, as I said, the scale. In the first case, we are talking about international levels. Here we are really speaking about local events. But it is, in terms of skills and experience, it is very close to each other.
That nuclear inspectors are going physically to certain sites, to fuel cycle facilities. But they are not there permanently. They go once per year or once every month or once per week, depending upon the sensitivity of the site. So one of the challenges for an inspector is to very rapidly and efficiently understand what has changed since the last time he or she came there. And this particular technology will allow you to identify geometrical changes, so building changes, a pipe which has been added or a door which has been created which was not there. And just driving around on the site, after a few, let's say 15 to 20 minutes for a site like Ispra, which has 100 buildings, you might be able to have, based on your computer model which runs behind, an indication of which changes have taken place.
So this is the sample cavity of the Pulsed Neutron Interrogation Test Assembly, or PUNITA as we call it for short. We use this instrument for investigation of methods and instrumentation that can be applied for nuclear security and nuclear safeguards applications.
That's why we've developed now techniques where we will start irradiating with an outside source, with an external source, and then we can detect in a more efficient way clandestine materials. So you have to imagine a container truck lane where on the top and on the both sides there is all types of sophisticated detectors, and from the combination of these signals you will be able to say this container only contains innocent materials or this container has nuclear material inside, even if it's very well shielded. But a key requirement for all the detection techniques we use in nuclear security is not to interrupt the normal operational flow, because we can check whatever we want as long as we don't create extra economic costs or extra delays for the shippers and for the transporters.
Certainly we do not issue any license, we do not do any control here. What we do is research in support to the policy. The policy implies facilitating the harmonized implementation of controls in EU 28. And one of the aspects is trying to apply the regulation all in the same way in EU 28 countries.
Is that we spend large amount of our time to train and educate people, because being a research center, developing all these types of fancy technologies, they are worthless unless they are being used in the field. And because there are only few locations in Europe where people develop this kind of technology, they come to us very often for a large amount of training, where we have many outside colleagues. We had Southeast Asian ones, we had the Saudi Arabian here, we had the Jordan here, we had Central Asian from Moldova, Kyrgyzstan, Kazakhstan, name them, African and so on. They come and they get trained here on technology which has been installed on their borders. If you have them training together, they will also automatically start to collaborate between them. They will get to know each other, and that's a very important feature of nuclear security and overall protection mechanism.